All right, guys, so this week we are going to be rolling into 12.3, the surface area of pyramids and cones. Pyramids and cones. So again, when we're talking about surface area, we're still just talking about as if we were taking wrapping paper and covering the exterior of the shape, or if we were painting the exterior of the shape. It has nothing to do with the inside. It just has to do with covering all of the surfaces on the outside of the shape. So there's a few pieces when we're dealing with cones and pyramids that are slightly different than when we dealt with prisms and cylinders and spheres. So the first new word, or not really new word, but something you have to take into account of is the number of lateral faces is equal to the number of sides the base has. So the base in a pyramid or a cone, there only exists to be one. When we had prisms, there were two bases. With pyramids and cones, there's only one base. It's that flat surface that it rests on. It's opposite of the apex or the top of the cone or pyramid. So the number of lateral faces, which is all of the other sides, are equal to the number of sides the base has. So just looking at our pyramid here, there is a full kind of 3D form, and then this is if we broke it apart and made it flat. So you've got two different versions to look at just to take into account all of the pieces. So the first piece we want to make sure we understand is that this is the base, and here it is as well. For this pyramid, it has a square base or rectangular base, and so it could also have a triangular base. It could have many different shapes as the base. It's not specific to a four-sided shape. Then we have our height. Remember, the height of all of our shapes that we're talking about has to be perpendicular. And the height for a pyramid comes from the tip top where they meet at the point and hits at the center at a right angle to the base. It's perpendicular to the base. So this is the height, and it's perpendicular to the base. And then we have our lateral faces. The lateral faces are, when you look at the piece that's laid out flat, the lateral faces are basically like the leaves that fold down or the sides of your pyramid. So those are our lateral faces, and these are lateral faces. And then the one last part that's going to be really important is something called the slant height. The slant height is the length from the tip top of your pyramid down the side of one of your lateral faces and connecting at a right angle at the bottom. This is your slant height, which we refer to as a lowercase cursive L. So if you're looking at a lateral face, that cursive L is going to be down one of the sides of your lateral faces. And so looking through all of the pieces of information we have down at the bottom, so a capital P, we've learned this on some of our other ones. The capital P is going to stand for the perimeter of the base. So whatever the base shape is, the perimeter of the base. That little cursive L is slant height. One year we had students, we nicknamed it the slell. I don't know, I don't even remember where that came from. It just came from like slurring slant height. And so sometimes you'll hear me refer to it as the slell. I'm sorry. And then the capital B, just like last time, was the area of the base. So we have the perimeter of the base, the slant height, and the area of the base. That is all necessary to find our surface area. So just like with our previous surface areas, we have to find lateral, and then we find the total. So for lateral surface area, we're going to take 1/2 of the perimeter times the slant height. 1/2 times the perimeter times the slant height. And then for total surface area, we're going to take lateral plus, and how many bases do we have? Look at that pyramid. How many bases are there? There's just one. So plus the area of the base.